Hello, good morning everybody. Welcome to CEI. This is Dr. Sekhar Chandra. I'm a teacher of chemistry. Today I'll teach chemistry and the topic will be the chemical reaction and chemical equations. Let's start chemical reaction. Now what is chemical reaction? Actually the change which will take place we can consider is a chemical reaction. Actually I'll teach today chemical reaction, different types of chemical reaction. So far we know there are a lot of chemical reactions are there, but I will teach mainly there are four important chemical reactions. They are number one, direct union, or combination or synthesis. Second, decomposition, or analysis, substitution or displacement, and double decomposition. There are double decomposition. There are mainly four different types of chemical reactions today I will teach. Though we know there are several chemical reactions, as far I know that you know there are so many different types of chemical reactions there, but according to your standard, there are the four types of reactions are very important. So today I will teach these four types of chemical reactions. The first one is direct combination. What do we call direct combination? Direct combination means just combination of the two or more substances together to form a new product, a new compound. That's called direct union, or this is also known as synthesis or combination. As for examples I can give you, there's the most important example will be carbon plus oxygen, that is carbon dioxide, or sulfur plus oxygen, that we know sulfur dioxide. Now this carbon, when it is burnt in air or oxygen, they form the carbon dioxide. Sulfur as well as oxygen combines with oxygen to form sulfur dioxide. Now if you take any metal, suppose Na, twice Na plus O2, 4Na plus O2 will get the Na2O. Or we can say calcium plus oxygen, calcium oxide. They all are combination reactions. You see that two elements, carbon and oxygen. There are two elements, sodium and oxygen. There are also two elements, calcium and oxygen. They form the new product, calcium oxide. Similarly, sodium oxide and other oxides of like carbon dioxide or sulfur dioxide. Similarly, CaO plus CO2. This is also an example. You can say calcium carbonate. This is also another example for the direct combination or direct union. Now, very important examples I can show you. That is PbO plus CO2 is equal to PbCO3. Now, important thing is the color of PbO. It is this yellow. This yellow, when it combines with the carbon dioxide or come in contact with the carbon dioxide, they form the lead carbonate, which is a white powder. This is called chemical reaction or chemical change, white powder. And other examples also given here. There are you see that this is the solid substances, but combined with the air or oxygen, they form the gaseous products, carbon dioxide. So we can see this direct combination or direct union. That means just direct contact with the two different elements or two different substances. They may be elemental form, they may be compound form, or any other form. They can be the new products. This is called direct union or direct combination. The second, decomposition. Decomposition is another type of chemical reaction. Decomposition is another kind of reactions. Chemical reaction is also very important, you know. That means when any substance or any compound decomposes into two or more different kinds of products, this is called a decomposition reaction. As for example, decomposition reaction is a very popular example. You know that heating of any carbonates, that is calcium carbonate, you know, the marble stone, when it is heated about 1000 degrees centigrade, we get the calcium oxide and carbon dioxide. Now this is the compound calcium carbonate. Decomposition means decomposes or break into two or more products. Here we get the two products, calcium oxide and carbon dioxide. Similarly, we can say PbCO3. When it is heated, we will get the PbO plus CO2. Interesting point is that it is a white powder. When white powder is heated, we get the yellow. Actually, it is orange when hot. It is orange when hot, and yellow when cold. This is a very interesting point. When it becomes hot, it is orange. When it is cooled, it becomes yellow. Similar examples we can say ZnCO3. These also decomposition reactions will get the ZnO plus CO2. The important part, this is the white powder. This is a white powder, but when it decomposes, it is a substance is a such oxide which is yellow when hot. Interesting point is yellow when hot. If I show you in the practical, it will be very interesting for you, but this moment is not possible. Yellow when hot and white when cold. White when cold. Similarly, there are several reactions or carbons are there which changes their color on decomposition. Now, another type of decomposition reaction I can show you, or you must know according to syllabus. Not only the syllabus is also for your interest. This is very important examples. There is lead nitrate, heating of the nitrate source. Now, when lead nitrate is heated, we will get the 2PbO plus 4NO2 plus O2. Now, this takes lead nitrate, it is a white crystal. White crystal. Now, on decomposition reactions, we get lead dioxide, nitrogen dioxide and oxygen. Now, interesting point, this nitrogen oxide is a yellow or reddish brown. Reddish brown. It's a reddish brown color gas or reddish brown gas, you can say. And this is already I told, it is orange when hot and yellow when cold. That the interesting part is lead nitrate, which is a white crystal, on decomposition, on heating, it produces a solid residue which is orange when hot and yellow when cold. With this compound, another product is obtained which is reddish brown fumes or reddish brown gas. Now, with this, oxygen gas is also produced, but oxygen there is no other color, so we can observe or we can see the oxygen gas. Only we see the two products. One is solid product or the gaseous product. Another thing in this reaction we can tell you that if it is performed in the laboratory, you will find some other observation. There is a crackling sound will be obtained. Crackling sound, and this crackling sound, with that crackling sound, this lead monoxide or lead oxide that will sticks to the glass wall of the test tube. Therefore, it is very difficult to remove the glass wall from the glass wall of this compound. So there are 4 characteristics observations we can conclude from this experiment, that white crystals on heating, crackling sound will be obtained. Secondly, reddish brown fumes will be obtained. Third is a orange when hot, yellow when cold residue will be obtained. And finally, this residue sticks to the glass wall of the test tube. There are 4 observations. That's why it's a very important for the not only exam or also for the subject chemistry. Now, one more thing I will give the examples. Copper nitrate. Copper nitrate on heating will get the 2CuO plus 4NO2 plus O2. Now see, copper nitrate on decomposition, this is blue color. This is blue crystal. This is the blue crystal. Now on heating, we get the solid residue, which is the black. And here we get the brown fumes. So we can conclude that on heating copper nitrate, we get the blue crystal changes to black residue with the evolution of reddish brown fumes of nitrogen dioxide, and another is colorless gas, which is not found during the experiment. So there are so many reactions are there. Decomposition. One more decomposition I will give you with the nitrate salts, that is called mercuric nitrate. Mercuric nitrate HgNO3 whole twice. That is on heating we get, interesting point here, that is on heating we will get the twice mercury plus NO2 plus O2. Now here you see mercury. Now if you balance there, we will get the 4NO2. Now mercuric nitrate is a white crystal. This is a white crystal, and on heating we will get the mercury that is shiny. You know the mercury color of the mercury, you know. That's the color will be, that is shiny gray globule, shiny grey globules are deposited in the upper polar part of the test tube. It looks very nice. If you see in the during experiment in the lab, if you find, then you will see that shiny globules are found at the upper polar part of the test tube, and with that again the dense brown films of nitrogen dioxide will be evolved. So we can conclude that white crystals changes to shiny grey globules upper polar part, and with the evolution of nitrogen dioxide. Now this is the nitrate. Not only that, one more example, then I will leave this decomposition reactions, that is ammonium dichromate. It's a fantastic reaction. If you perform in the experiment in the laboratory, we'll get this reaction will take place, and this equation or this reaction occurs. Ammonium dichromate N2 plus Cr2O3 plus it will be 4H2O. Now this is orange crystal. This is orange crystal. This is the nitrogen gas, and it is a green residue, green powder. Now we find when it is heated in a test tube, we see that some burning flame, or I can say this reaction is known as chemical volcano, because it looks like the volcanoes, but in a very simple way, because it is reaction, or this reaction is carried out in a test tube or in a container. So we can say it is a chemical volcano, a simple form of the actually volcano, and the reaction when it takes place, volcanic eruption takes place, and with the green powder, and we will see the reddish flame or red flame will be evolved, will be produced. We'll find the red flame with the green powder, and some glowing sound will be obtained. This just looks like a volcanic eruption. So this reaction is known as chemical volcano. This is known as chemical volcano. So no more examples I'll give you for the decomposition reaction. Next will be the substitution reaction. Third type of reaction will be the substitution reaction. Now substitution reaction, what is that? Substitution substitution reaction will be such type of reaction where one of the component or one constituent atoms or elements will be substituted or will be displaced or replaced by another element. That is called substitution reaction. And the most common examples will be the, suppose, copper sulfate plus zinc. Then it will be zinc sulfate plus copper. Now you see, copper sulfate is a copper, one of the element that will be substituted by zinc, and it takes its place, zinc sulfate, and copper will be free as Cu. So this is called substitution reaction or displacement reaction, because zinc displaces or zinc substitutes copper from copper sulfate. That's why it is called substitution reaction or displacement reaction. But the most important part of this reaction is observation. What will be the observation? Now this is the blue solution. And in the blue solution, when zinc rod is dipped inside the blue solution, then we will find the solution will become colorless, because zinc sulfate is colorless and copper will be the reddish brown deposit. Reddish brown deposition takes place. So when zinc rod or zinc plate is kept inside a beaker containing copper sulfate, we'll see that gradually the blue color disappears, and on the zinc rod or the zinc plate, copper deposition takes place. That is, copper means reddish brown deposition is taking place. Now similar examples we can give. There are so many examples are there. At the end I will give the questions for regarding this type, but some important reactions I am telling you. Ki, potassium iodide plus chlorine, or potassium bromide plus chlorine. In these two cases, we can say it will be 2 KCl plus I2, and here it will be 2 KBr plus I plus 2 KBr 2 KCl plus Br2. Now interesting is Ki, which is colorless solution. This is colorless solution. This is colorless solution. Now when colorless solution, chlorine gas is passed. Chlorine is a greenish yellow gas. This is greenish yellow. This is greenish yellow gas. When this greenish yellow gas is passed through Ki solution, colorless solution, we will find that violet color, colorless solution will be there, but some violet coloration, violet colored gas, violet, because you know this iodine is violet color or pink color, violet color gas will be evolved, but this violet color gas I2 will combine with the Ki to form Ki3. This form Ki3, which is reddish brown solution. Ultimately, the interesting part is, in aqueous solution or colorless solution of Ki, when chlorine gas is passed through it, greenish yellow gas is passed through it, then this colorless solution changes slightly first pink and then gradually changes from pink to reddish brown color. Reddish brown color, why reddish brown color? That is colorless, pink, and finally reddish brown color. Why reddish brown color? Because this iodine will combine with the excess of Ki to form Ki3, which is reddish brown color. Similarly, in this case, now KBr is again the colorless solution of bicar, and we are passing through greenish yellow gas through it. Then we find this colorless solution turns to again reddish brown, because we know bromine is a reddish brown gas and which dissolves in water to form HBr or HOBr, which is brown color, and this is colorless solution changes to reddish brown. So this is the interesting reaction for substitution reaction. Not only substitution reaction is important, but it is a very colorful reactions and important for the subject as well as during examination, also very important. One more example I will give you for this reaction, otherwise it will be incomplete. That example will be the action of metals on acid. Action of metal on acid. Suppose HCl plus Zn or HNO3 plus Mg or H2SO4 plus Fe. In all these our examples will be the substitution reaction, because Zn will replace chlorine to form hydrogen to form zinc chloride, and hydrogen gas will be released. Here magnesium will replace hydrogen to form magnesium nitrate, and hydrogen gas will be released, and here also FeSO4 plus hydrogen gas will be released. So in these cases, zinc, what will happen? Zinc substitute hydrogen, and then hydrogen gas will be released and it takes its position to form zinc chloride. Magnesium substitute hydrogen and hydrogen gas is released and it takes its position to magnesium nitrate. Similarly, Fe also substitute hydrogen to form FeSO4 and hydrogen gas is released. Now these are three kinds of reactions today we are discussing about the substitution reaction. And finally, the another and final reaction, chemical reaction, that will be the fourth will be the double decomposition. Another very important and interesting reactions, chemical reaction. That is called double decomposition. And this is the last one I'll discuss now, and then I'll conclude finally regarding the different types of interesting questions and interesting phenomena. Double decomposition means, now when the constituent elements or constituent particles of the reacting substances mutually exchange their positions, then to form the new products, this reaction is known as double decomposition. I repeat, double decomposition is such type of reactions where the constituent particles among the reactants molecule rearrange or mutually exchange their positions to form a new set of products are called double decomposition reactions. Now examples, let me give you one by one interesting examples. Suppose barium chloride BaCl2 plus sodium sulfate, we get barium sulfate plus 2 NaCl. Now you see, I told that reacting substances are barium chloride and sodium sulfate. Now in this case, I told that they mutually exchange their positions. Suppose barium position takes by sodium to form sodium chloride, and sulfate takes positions of chlorine to form barium sulfate and sodium chloride. So they mutually exchange their position. Now sodium will take place, will take barium place, and sulfate will take chloride space. So barium sulfate will be obtained and sodium. They mutually exchange their positions, nothing more. But the interesting part is barium chloride and sodium sulfate both are colorless solution. Both are colorless solution. And when they mix together, then we get white PBT of barium sulfate. White PBT of barium sulfate. Similar example, silver nitrate plus sodium chloride. We get what? Silver chloride plus sodium nitrate plus sodium nitrate. Now you know that silver nitrate is a colorless solution. Sodium chloride also, you know, the Tata salt, the aqueous solution will be all colorless solution. But interesting part, when they mix with each other, we get the white PBT of silver chloride. White PBT of silver chloride, and NaNO3, you know, the aqueous solution, and these are no takes part in the chemical reaction, don't takes part in the observation. But observation, both the colorless solution, when they mix together, will get the white PBT or milky white PBT of silver chloride. Now these are called precipitation reactions. Similar, one more example, it will be incomplete if I don't tell you. Lead nitrate plus Ki, lead nitrate plus Ki, we get PbI2 plus twice NaNO3. Now the interesting part, lead nitrate is a colorless solution, you know. Potassium iodide is also colorless solution, but when they mix with each other, we get what? PbI2, and you know PbI2 is a yellow precipitate. So both colorless solutions, when they mix together with each other, we get a yellow precipitate. And this yellow precipitate, whether you know or don't know, but the interesting characteristics of this lead iodide, it is soluble in hot but insoluble in cold. And when lead iodide, this iodide, when you mix with water and then boil in water and then boil in a burner or any heating arrangement, then we will find that gradually it dissolves, and then again it forms into colorless solution. And when this colorless solution is cooled under tap, we get some shiny crystals, shiny brown or shiny golden crystals are found, which is called artificial gold, and we can prepare artificial gold, that is PbI2. So PbI2 is this reaction is important because it's very colorful reaction. Both are colorless, but when they mix together, you get a yellow precipitate, and this yellow precipitate, when boiled with water, or it is heated, then it gradually dissolves to form again colorless solution. And this colorless solution, when cooled under tap, we get the shiny golden crystals, which is known as artificial gold. Just looks like gold, but since it is artificial, it is called artificial gold. And just one more example I'll give you, then it will complete this topic, or these 4 types of reactions I'll complete it. This reaction, suppose FeCl3 plus NH4OH, we get FeOH whole thrice plus 3NH4Cl. Now FeCl3 is a yellow solution. This is yellow solution, and this is colorless solution. And when they mix with each other, we get the reddish brown PPT. So when the colorless solution and yellow solution mix together, we get the precipitate of reddish brown precipitate, and this is also double decomposition reaction. This is because this chlorine is substituted by 3OH, we get a ferric hydroxide. Similarly, iron will be replaced by ammonium to form ammonium chloride. Double decomposition, they mutually exchange their position. So this is one example for the double decomposition. So I'll conclude that there are 4 types of chemical reactions, very important. Though we know there are several chemical reactions there, at least more than 10 reactions are there, but this is not included in your syllabus. Higher classes you will study. So no more here. The question next time I'll give the questions because time will not allow you. So let me complete my today's teaching. If you like this video, please do share, like and subscribe. Thank you so much.